For everything else on that worksheet, we've been using V equals W over Q. And sorry I'm writing so slow. I'm having to write with my finger like on my touchpad. I still haven't got my slate to work right. And so the units for work is joules, and the units for coulomb or for Q is coulombs. And that's what we've been doing for most of them, right? And then joules per coulomb is a volt. Now this last one, they don't want that. They ask you for they give you a volt. I'm just going to make up a different number. But I'm not super creative, so I'm going to do 4,000 instead of 4,600. That's why I'm in science, right? Instead of art. And then they give you a Q, which is a charge, and they have like 3.2 times 10 to the negative 7. So I'm just going to do 3 times 10 to the negative 7. Now, since they already have it in coulombs, we don't have to actually convert it to coulombs. If they had just said like, if they had said 30 UCs, then we would have had to convert it to coulombs. But since they've already got it in coulombs, and the way you can usually tell that they've got it in coulombs is, you know, it's this really tiny number. So since they've already done that, we don't have to do any conversion, which is nice. And then they ask you for the energy, right? And then we've been using this formula that's like V equals W over Q the whole time. So it's like, what the heck? Well, I don't know if you guys remember, but the units for work is joules, right? And then the units for energy are also joules. See, I'm really terrible at writing on my touchpad. So we can actually take this formula that we've been using all through the worksheet, W over Q, and turn it into E over Q. Since these two have the same units, it's not going to like mess up our units. We're still going to have, you know, joules per coulomb, which will then give us volts. So we're actually basically using the same formula. We're just putting E in the top instead. So I'm going to do E over Q. And now I'm going to have to solve for E because that's what we're looking for. But believe it or not, I majored in biology. I'm not an algebra person. So I'm going to draw this triangle. Have you guys seen this triangle before? Did they show you this in the video? So you can just put the formula in here. So you've got like, yeah, V's on the left and then E over Q. So E's on the top and Q's on here. And so since I'm going to be looking for E, I'm going to kind of cover that one up. And that means E is equal to V times Q. So now I can take my my 4,000, these little teeny tiny O's or zeros. Really need to get my tablet working. I worked on it today, but it's old and the software's out. Times 10 to the negative 7. So, and then if you're going to put this in your calculator, I highly recommend putting it in parentheses like this. I've seen a lot of people, not just in our class, but like in other classes I've taught too, not put, especially things that have exponents, not put them in parentheses, and then they get the wrong answer. They've got it all set up correctly, but they don't put in parentheses, and the calculator does like 4,000 times 3, and then times 10 to the negative 7 or something like that instead of 3 times 10 to the negative 7 times 4,000. So I highly recommend putting it in parentheses like this. And then, let me see, I'm going to type it in my calculator. And I got 0.0012. Is that what you guys got? And so, and then you can make sure you do joules. And then you could also have written it 1.2 times 10 to the negative 3. You can write it either way. So did that help? Maybe, I don't know. I'm just waiting for you guys to see what you were saying.
Can you hear me?
Yes, yes.
Hey, I'm sorry. I was trying to unmute my microphone and my computer was lagging so bad.
It's okay. It's okay. These
Okay,
these
yeah,
sessions take up a lot of bandwidth and stuff on your computer.
it does. But yes, that definitely helped. And on that same page, on that same
Uh-huh.
worksheet, um, that helped on that one. And on that
Oh,
same
I just did
voltage
6 for you,
worksheet,
didn't I? Instead of 5.
that's okay. I
Sorry.
just had trouble understanding 5.
So let's go back and do 5. Sorry.
Okay, thank you. It's
Okay. Like I said, I'm not sure how to. Says that we have a 6-volt battery, so I'm gonna I don't know when I got in this habit, probably like back in middle school. I always write what I know on this left-hand side. So we have our volts of 6. We have 3,200 joules of work. And then it wants the charge. So my students in the face-to-face classroom, they like would always get upset with this word magnitude. They thought it was like it basically just is like amount. When they say what's the magnitude of the charge, they just want like what is the charge. They could just say this and it would mean the exact same thing. It's just they like to use big words in these things. So we're going to use that same formula, V equals W over Q, except this time we're going to solve for Q. So I'm going to put it in my triangle again so I don't have to do any algebra. And I like to solve, get all my letters like where I want them before I put in my numbers, because I found that I'm a lot less likely to make a mistake when I'm moving all these letters around rather than moving a lot of numbers around. So that's why I do this first. But I've known students that will actually draw the triangle and they'll put 6 here and 3,200 here.
So, quick
Yeah,
question. E is the same thing as W because they're the same unit.
yes, yes. Now that's like the only one that's easy like that. All the others have like,
Okay.
see, work is joules and Q is coulombs and current is, the symbol for current is I, but the units are A. That's the weirdest one to me. So you can put your numbers in like that, but I don't know. I've just never gotten that habit. But I have seen students do that because then you know you're doing 32 divided by 6. So I'm going to do Q, and I'm going to do 3,200 divided by 6. And I'm going to get, what did I get when I did this? 533.3. Now, I've seen when people are turning it in that they're writing like 530. Some of you guys must have teachers that are like really particular about sig figs. Because I've seen a lot of people writing 530. I've seen like 5 times 10 to the 2. I've seen 5.3 times 10 to the 2. Really, you can do any of those. I, I know that you got the answer. Um, so, yeah, you can, all of these would be considered right. It's, it's just some people are really into sig figs. I never really got all that crazy about them, so I don't really care about sig figs. But does that help?
That helps a lot. Thank
Okay,
you.
you're welcome. Good. Do you have any other questions?
Not right off the top of my head, but I'll go look back in my notes.
Okay. Um, so while you're doing that, I'll kind of just jabber on. Um, so there are a couple virtual labs coming up, like the one we had last week, where we had to we did that in the Adobe session. We can work on that Adobe session for that week before they're due. Or you guys can do them at home. I went through them and I added some more instructions to them, like I did the time before, because like I said, we just get popped into this course, and I looked at the instructions for a lot of the virtual labs. And I'm like, okay, it's not immediately obvious to me what to do, and I know kind of where it's supposed to be going. So if it's not immediately obvious to me, it's probably really not obvious to them. So I added some more in there, and I put all of those hints. I put them in the user link section of the course, but I also put them in the Dropbox folder for that assignment. So if you can't find them there. So when you start getting to those virtual labs, just know that I think for all of them, I've made an extra document that has more stuff so you can figure kind of more instructions so you can maybe figure it out a little easier. Did you find your other question? Or did you have one? Okay. Um, it's kind of hard, this beginning stuff. There's not like a ton of math. There's not a ton of things to do. Um, here's this review sheet I had. I'll bring this up towards the end again. But what we can do, I guess if you guys, if you want to leave, you can. I actually have to be here for the full hour. So instead of just sitting here, you know, just twiddling my thumbs, I'm gonna maybe work through some series and parallel circuit problems just because I'm stuck here anyway. And that's what we'll be doing next week. So if you want to stay, you can and get, kind of get a little bit ahead, or you can go. I totally get it. I know you guys are really busy and have lots going on. So it won't hurt my feelings one bit. Um, so okay. So we have this the video has this Ohm's law problem set. So I think I'm gonna work through those. Like I said, if you want to leave, you're more than welcome to. It won't hurt my feelings one bit. Let me see if Anna has a question pertaining to this week first. Hi Anna, I put your microphone on, so you should be able to talk if you want to ask a question of talking instead of typing. But just keep in mind, if you don't mute yourself, if you know, anything that you say or is in the background of wherever you are, we'll be able to hear it. So if you go to the top of the screen where the little microphone is, you can just click on it and you can mute yourself if you want or not. It's totally up to you. But do you have any questions or? Okay, well I'm just gonna work Ohm's law problems and then